Good evening, everyone. It's my pleasure to welcome you all to today's session of the FDP on Responsible AI, organized by PSG College of Technology and sponsored by AICT ATAL. Let us begin today's session with a thought-provoking quote by Albert Einstein. The world we have created is a product of our thinking. It cannot be changed without changing our thinking. This quote resonates with the essence of responsible AI, where ethical thinking and innovation come together to shape a better and more inclusive future. With this inspiring quote, I, Dr. S. Surya, will introduce the speaker of today's session. It's a great honor to introduce our esteemed speaker of today, Mr. Jayant, Chief Development Architect at SAP Labs India, Bangalore. He believes in a systems approach with the people and design thinking as the prime drivers towards any business. Conceptualization of products is what that keeps Jayant busy every day. In his current role, he's working on helping to change the culture of SAP and drive innovation among its 35,000 engineers by designing and driving programs around SAP, quantum computing, and fundamentals of AI. With nearly 20 years of experience in IT industry, he has worked on various architectures of large enterprise-grade products. His innovation streak has led to various patents and open source projects that he is a part and maintains the same. He regularly teaches and speaks at various universities on topics of system thinking in software architecture. Apart from this, he consults various NGO organizations on a pro bono basis on technology. He is also a tech mentor to India Inclusion Summit. We are excited to learn from his expertise and looking forward to an engaging session. And over to you, sir.
Thank you, ma'am. Thank you for the introduction. Do let me know if you're able to see the screen.
Yes, sir.
Perfect.
It's absolutely visible for everybody.
Thanks a lot, ma'am. Thanks a lot for the wonderful introduction. I love the quote. I love the quote that we have to change ourselves. And it is no lie to say that in the age of AI today, this is absolutely true. Probably as what Dr. Surya said, a quick brief introduction of who I am. As introduced before, I have been with SAP now for nearly 20 years, so I'm pretty much old furniture in the company. Started my career actually in banking software. By education, I'm a mechanical engineer, but you know how things were back in those days, early 2000s. So I moved into developing banking software, specifically in the domain of retail banking, which is what you use as ATMs. I started developing ATM software for Citibank and then moved on to other different aspects of banking software. Then joined SAP, continued my software in building in the financial space. I got into some exciting area called financial forensics, where we had to probe fraud and detect fraud and analyze different types of fraud in all the customers of SAP. Eventually, through different ways, different roles within SAP, got to developing the architecture for even the latest GST. And now I'm kind of leading the entire program and development of program and deployment of program, where we develop different programs to help engineers of SAP learn the newest technologies inside and outside SAP, but also SAP customers and partners to learn various things. You can find me on my handle there in all these three platforms, GitHub, LinkedIn, and Medium. I try writing a little bit whenever I find time. Yeah, once in a while, I try doing my pilgrimage to the Himalayas every year on trekking, hoping to clear my mind for the next year. So yeah, that's about me. But one of the things I'd like to bring up as an early warning system kind of a thing is some of these things that I'll be speaking today is not directly related with SAP. These are some of my opinions of having interacted with various people from the industry, from various walks of life. And all these opinions are mine, so nothing will go back to what SAP or SAP's entities are in terms of any of the things that I'll be sharing today. Why listen to me, actually? I mean, what's so special about me? If you really think about it, I haven't developed any responsible AI mechanisms or new algorithms or new systems or anything. But I've been very, very fortunate through various instances of meeting different people across different facets of life, and having had done deep discussions and deep interviews with them, I have learned a little bit of what this space means, what does responsible AI mean, and how it is going to affect our lives in different ways. Some of the people I've met is the bottom left corner here. Is with Brian Christian. He's written a wonderful book called as The Alignment Problem, which is how does the intent of machines and the intent of humans, how do we align it? What do we do with it? So I had a chance of interviewing him multiple times uh, across multiple different forums, multiple different types of people who were in the audience. So I learned a lot from him in terms of what does responsible AI really mean, and in terms of humanity, what does it really mean? I had a chance of even interacting with Jerry Kaplan, that is on the top center of the screen. Jerry Kaplan, for people who don't know, uh, he's the one who invented the stylus, actually. If you use Apple Pencil or any kind of stylus today on a graphics tablet or on your iPad or Android tablet or even on your phone, he's been credited with that invention. And he was he had invented e-commerce sites before e-commerce sites existed. Generally in the world, we believe the very first e-commerce site was actually eBay, but Jerry Kaplan had invented a thing much before that. Today, he's teaching at the Stanford University, where he talks about the history of AI and how AI came out to be over the last, say, 50 years, from the earliest thought processes of just plain simple perceptrons and neurons to where it is today. And I had a good interaction with him multiple times, actually, to understand how AI is shaping humanity back then, now, and what he thinks is going to be in the future. Top right is Brewster Kahle. Brewster Kahle is the guy who invented internetarchive.org, which is basically the project to archive the entire internet. So he has the expertise of understanding how do you archive petabytes and exabytes of data. Had a chance of interviewing him also. Again, his views are very, very unique. And just about a month or 2 months ago, when I met him, they were actually gathering in a small little forest/wood near somewhere near in California, where a lot of the experts are sitting down and trying to discuss some kind of a guardrail mechanism as to how humans should behave with humans when AIs become smarter than humans. Completely different kind of topic. Below is actually Viral Shah. For people who don't know Viral Shah, he is the creator of the Julia language, one of the main languages being used in most of the labs around the world, specifically to build deep AI-related products or deep, let's say, dynamical systems products as of today. So what I have done in this presentation is I have tried to gather wisdom from different areas in different walks of life, from different people, and a little bit from my own experiences to put together what does a responsible AI mean. Dr. Surya had told me that this is going to be a group of people who know what AI is, but I'll risk the next 5 minutes probably to go through some of the basics to kind of ground all of us, if not many people know how some of these things work, so that we are all on the same page, and then we can actually have a much deeper understanding of what does responsibility of us and also of AI mean. Typically, I'm open to questions, but since this is an online format, would love to see questions on the chat if possible, so that I can answer them, or probably during the end of the session, I could answer more. So getting into it directly is typical traditional programming approaches is there is a certain amount of algorithm we build, which creates a certain amount of data, or data already exists, either ways. We bring that together in some kind of a compute, as in trying to do some calculation, trying to do some kind of search or something in that sense, and there's an output. Typical example from my own life is when we did GST. There is tax data. I think all of us know what the tax data is, the invoice amount, product, things like that, state, country, or is it an interstate movement, things like that. And then there are tax rules, which is policies established by the government or established by the GST Council, which we kind of use to guide the whole conversation as to saying what should an individual pay, organization pay, or a state pay, or finally at the highest level, two states paying each other, or the center and the state paying each other, and things like that. All these things come into some kind of compute, and then finally there is an output which kind of puts together as to, okay, this is the amount of tax you need to pay, or this is the amount of tax you need to claim, or whatever that is there. Now, these are algorithms driven by humans. These are forms driven and written by humans. And the data that comes together is actually human generated. So in all senses, the rules, the data, and the mechanism of obtaining the data is actually human generated. It is not it is not automatically generated in different ways most of the times. Of course, if you look at pure sensor-based applications and things like that, yes, it is more giving more realistic data from different sensors, but in essence, this is the kind of, let's say, flow that is typically followed in a typical programming approach. But if you look at what's happening today is completely different. Today, we are having a lot of data that's coming in a multimodal sense. When I mean multimodal, I mean text, audio, image, or video. Video is a combination of audio and images, if you really break it down to its most fundamental unit. And a kind of having a certain amount of labels associated. Labels means to say, for example, in an image that there's a bird or a flower, and somebody has labeled it that there's a bird or a flower, or like how Google Photos does with us, as in saying it takes my face and my wife's face and says, okay, I know this person and I know this person, and I will search more on this person. Now, this kind of an approach is not explicitly algorithms written by humans. It is an algorithm that gets generated over a period of time. I will explain it more as we go along, and kind of self-corrects by saying, okay, I tried to say that this is a flower, but the label is saying that this is, I don't know, maybe some kind of a toy. So maybe I'm wrong. I have to correct myself, and I have to correct myself, and I have to correct myself. These are the kind of programs that are actually functioning today, rather than rule-based approaches. It is more discovery-based approaches or self-correcting approaches. Typically, these are called as function approximators. Now, in a very simple way, if I have a simple curve, or if I have a simple equation which is generating some sort of a curve, this curve is going to be fit based on either an equation, or the curve gets discovered based on the kind of data set that I have. Let's say I just throw X and Y points, and I throw it through a neural network system of today. It'll actually try and generate an approximated curve, determining what that data set is. So what best humans could do so far is actually come out with different types of equations, simple equations, first order, second orders, or whatever that we have done so far. But or rather, after coming with the equations, it led to different types of data. But here we are going the other way. We get the data first, and then we come out with the equations. We come out with the algorithms. So if you see the difference between the previous approach, where we know the rules, we code the rules, which work on data and give us output, to we give data and it discovers the rule on its own, and then we work with that output to correct it, to remove errors, or to remove any problems or anything that is there. So what happens in this kind of an approach is, say, for example, in the previous approach, which is the tax approach, we had said there's going to be product and there's going to be state, and these are two parameters which is going to determine what is the tax rate. Now, this is only 2 parameters in that equation, but actually there could be many more parameters. It could be maybe that we had to charge a certain tax rate based on the income status of a certain person who's buying. Or it could be that it should be based on the weather patterns of a certain region, because, say, for example, recently there were floods in southern India. Now, certain products should not be taxed when there are floods. This situation will never happen. The situation is not dynamic enough to surface things up. But if we have the data, and if we are able to put all this data together, maybe the system will be able to recommend the best possible approach of how you deal with tax, just as an example. Now, the situations keep changing. It's not going to remain constant, as in floods happen, next cycle maybe a drought happens, next cycle maybe something else happens, or whatever that is there. Now, the way the system has to behave has to be different at different points in time, which brings us to the fact of that it has to continuously learn as to what these different points in time are and how the state is changing at each point in time. So A, we have moved away from algorithm to data. We have moved from data to algorithms. B, it is continuous, as in it is constantly changing. And C, we are seeing that there are hidden correlations between patterns which we haven't thought or seen before. Say, for example, the weather and the tax rate, just as an example. Now, all this, if you really look at it, in the first approach, it's highly deterministic. You don't want your bank statement going wrong. I have worked in financials for nearly 25 years. Nobody likes to see a difference even in the 5th or 7th decimal place in a balance sheet or a bank statement. So that's a deterministic approach. But what we are seeing that is emerging is more stochastic based or probability based approaches. This can be applicable to all use cases. Say, for example, definitely I don't want balance sheets going wrong even in the 7th or 8th decimal place. That's non-negotiable. But I don't mind if it tags my face incorrectly in a photo, which I can correct. It's not going to create that much harm, for example. So this is the new world versus the old world. The old world being that of algorithms to working on data to get with output, to the new world of data getting data actually determining what is the algorithm or what is the function that should be there. So how does this whole thing work? I think the basics are very, very simple. Everything is data at the end of the day, and all data is numbers. Doesn't matter whether it is text data or whether it's image data or anything. It's just pure numbers. So in the language of AI, we treat everything as a vector or a matrix. It's much easier if it is table-based data like RDBMSs. It's much simpler because we'll be able to denormalize the entire database, bring it as one huge table with all the relations possible, and ask it to learn, saying, you know what, if tax rate is this, if say, for example, product is this, if weather is this, if something else is this, on and on and on, then you should give a discount in the tax rate or by 5% or 10% or whatever that is. So these are the labels that get associated with, and this is the large amount of data. Similarly, images are just pure pixels, which is RGB combinations, which is numbers. So we are able to handle that. Audio is a little more harder. When we work with audio, we don't directly work with every sub nanosecond sample and say what is the frequency, what is the tone, what is the volume, loudness or anything. It is much harder because we have to sample at a certain rate and work with it. Text is what you're seeing today with all the chat GPTs of the world or Geminis or Claudes of the world. There's a much better way of representing it. It's called as embeddings. We'll discuss a little more on that. But what is coming up and getting more interesting, and which is more relevant to the topic as we go along in the responsible AI space also, is 3D space information. So far, we have been neglecting, say, for example, how an object looks from the human perspective in a certain way, versus if I go exactly 180 degrees on the other side of the object, it might look different. A three-dimensional image could have different amount of depth, a different curvature, and things like that. How do you capture all this into AI so that it's able to make sense of the three-dimensional world in a complete way? I had the lucky chance of meeting Dr. Feifei Li at a book signing event, and eventually we had a short discussion also, where she kind of had given a roadmap of how she plans to bring three-dimensional data of the world into learning modules or learning models for AI to learn from. She was the first person who created ImageNet, which figured out how to bring in, I think 15 million or 150 million, I missed the number out, the number of images, and kind of train them on different labels. And finally, that's when we started seeing, after I think 1 or 2 years with Alex Krivetsky, who started working on image recognition. And by year 2 or year 3 after the data set got released, AIs were able to recognize images much better than what humans did. So she's trying to do the same thing for 3D data of the world. She just floated her company called World Labs. It's very interesting. You should keep in touch with it. And a lot of other people are doing great amount of work in terms of figuring out how do I convert other modalities such as smell, taste, touch into becoming numbers or vectors and matrices that these neural networks can work upon and do something with. So this is a very exciting approach to see that anything and everything is actually a floating point number in a vector or a matrix, and we are able to work with it so beautifully because of the fact, which we saw in the earlier slide, that once you're giving data, the approximation of the function is happening, and the approximation of the algorithm that it has to work on is actually happening. So how does this actually fully work finally? If you really think about it, learning in general, learning even in a human brain, if you speak to different neuroscientists, they say that learning is about making mistakes and doing, or rather the human brain actually works in a slightly different modality in terms of it practices and make mistakes. So it plays and makes mistakes before it actually does the real thing. So there's something called as simulation, or we talk to ourselves in our own brains and we think about something back and forth in terms of if this, then that kind of a scenario. And finally we say, yeah, I'm going to do this. And once this is being done, if you're missing the target, you actually adjust in real time, pretty much. So I don't know if really the human brain is doing zero-shot learning, because it's not that, the day a baby is born, the baby knows I should not touch hot things. There is a certain amount of play that happens physically, and that gets wired into the brain in terms of the data set, and the brain is actually figuring out whether I should do this or not. So the way it does this, whether it's in the brain or it's in the neural net, is actually what we call as function optimization. Learning is just gradient descent to the minimal point of a certain function, which is the minima or the maxima is what we call in typical function language. Learning is just gradient descent that is coming towards, or the rate at which it is coming towards the minima point of a certain function. The way it does that is it tries it, and if it fails, and if it's not getting the right amount of value, it corrects itself, adjusts itself, the algorithm adjusts itself, and then tries again and sees is it going towards the minimum. So if you really think about it, it's just pure going towards minima, and inverse of the minima is maxima. It's pure going towards the minima in terms of, say, for example, a neural network trying to learn pictures of a cat is actually getting trained by looking at all the pixels and saying, am I reaching cat? Can I determine this as a cat? And the cat is actually the amount of error, which is nearing zero, not exactly zero, but which is nearing zero, which is minima actually. And that is where the weights and the biases in the equation, say, for example, if there is an equation of ax1 plus ax2 plus ax3, a1 and a2 and a3 being the weights, and x is the parameters, which could be RGB colors, or it could be, as I said, weather patterns with tax rates, anything. The weights get self-adjusted along the way in terms of learning this back and forth. And this takes many, many iterations. It is not just a simple approach, but it is trying to see, can I reach the zero at some point in time? Now, this is pretty much an oversimplification. If you look at today's state-of-the-art function approximators or function optimizers, they work with billions and in some cases even trillions of parameters. It's not even comparable to what we are saying in terms of denormalizing all the tables in a data set and saying, take it. That's nothing for it. So if you really start looking at this approach, you are going to see that the function optimization is only going to improve over a period of time because the math algorithms or the compute that we are throwing behind it is becoming better and better to reduce the amount of error in terms of am I predicting the right thing or am I predicting the wrong thing? So this back and forth is happening similar to the human brain. So it all starts with I'm trying to predict something and it just gives a random weight and a bias, say for example in the first image, and it starts the gradient descent coming down. It ensures that it's a gradient descent coming down. If it has given wrong weights, it might overshoot the minima, and it says, okay, I have overshot the minima because my partial differential equation is now showing that I'm climbing up again, which is not good. So it comes down on the other side. Again, it has adjusted or fine-tuned those weights appropriately. It might overshoot a little less, but it still overshoots. And then finally, it comes to saying, I'm pretty much there. It's not that it's perfect. We don't get, a zero minima. That's pretty much not there because the error is in the number itself. We can handle FP32 numbers, floating point 32 numbers. So there is going to be some amount of error there, but it's there. We are nearly there. So it brings that with a certain amount of confidence, maybe 97, 99, and saying, you know what, I know this is a picture of a cat. So this is typically how function optimization works. But how's this all coming together? This is coming together. I think you must have seen this slide or some picture similar to this, where we say that there are different types of learning. So learning is just gradient descent, as we saw, and trying to minimize the error, whether it is humans or whether it is machines doing it. But we have given different, let's say, connotations to learning. We call learning as supervised learning when we know that there's a label behind it. Say, for example, if I have 1,000 images of a cat and I say this is cat, that's supervised learning. I'll be able to give 1,000 images out of which I'll tell, learn from 800 images and 200 images, try guessing and see if your guess is correct. And if it's not correct, relearn again, adjust your weights again and try guessing again. So this is this practice which even humans do. The same approach is what AI is taking. It keeps continuously going through it. This is supervised learning. Unsupervised learning is, okay, I have means, I'm not able to still label it. Say, for example, in the previous example, I was telling you about Dr. Fei Li, who's trying to bring 3D spatial data coming into AI. How do you label 3D spatial data? As in, if I take, say, for example, something sitting on my table, let's say a pen is on the table or a pencil is on the table in front of you. Now, it's very easy to say for you that the pencil is there. Yes, and if you label it, even the AI is able to recognize that the pencil is there. But if I tell you to bring out the spatial data of it, it's very difficult in the sense of, A, you need to pretty much bring out every single XYZ point out of it. B, you need to figure out the texture and the orientation and things like that, which is a little more subtle and not just plain XYZ data that comes out of it. C, which is even more harder, is how's the light bouncing off? What's happening with the light characteristics at this particular moment in time with this kind of light setting? In the morning, the same pencil will look a little different. The shadows cast are different. But at this point in time, it's different. How do you bring all this data in? These are not labeled data sets. You can just bring in the raw data saying, I know that this particular point on the pencil is having X amount of lumens of light falling on it. Or I know this particular point is XYZ in space and things like that. But we can't exactly label it saying, this is a cat kind of feature. You can't label that way, this data set. So what we do is we take that data set and we tell the algorithm saying, hey, look, I don't know what this data set is saying. but can you figure out some kind of buckets or clusters that you can put this data set into, or these different records into? So it will be able to bring out a pencil, and it'll be able to put that together, and all the pencils that you're shown to it in 3D space, it'll be able to put that together. Now there is no labeling called a pencil, it's able to put it together. Maybe it is a pencil, maybe it's a chopstick, or maybe it's a pen, but it's able to put it together at least. So such an approach towards learning is unsupervised learning. Now both these learnings, which is supervised or unsupervised learning, go through the same optimization functions, or trying to build the same optimization functions. They don't do it differently in any way. The third part of it is reinforcement learning. In reinforcement learning, what we try and do is, it's like teaching a kid. If the kid does the right thing, you reward and you say, hey, great job done. If the kid doesn't do the right thing, you punish. Say, no, this is bad behavior. You're not supposed to do this. See, daddy is not happy or mama is not happy. That kind of a statement is given. So this kind of corrects the learning, or corrects the gradient towards the right path. So there is a label. The label is not a direct label as a cat, but there's a label as in a system to be in. And that label is what you're trying to navigate towards when a certain system is trying to learn something. So that approach is called as reinforcement learning. Now, this whole thing is being encompassed by another term called deep learning. Everything is deep learning now. There's no more pure machine learning that is being done pretty much in almost all industries. So we still think about it from these three perspectives. So having said this, if I just described supervised, unsupervised learning just for the sake of slides, I have put it here. And I said reinforcement learning also. So having said this, all this is actually culminated in the highest form of what we humans have done so far, which is write lots and lots and lots over centuries and gathered all this knowledge. Now, all this knowledge in some way is some form of compression of humanity itself. If you really think about it, we are who we are today because of previous generations leaving their footprints in terms of their knowledge, in terms of writing or in terms of speech or anything. I mean, Indian tradition is more oral than written, but there's a lot of written tradition also. If you really think about it, all this is actually just knowledge being compressed and knowledge being passed over to the next generation. Now, unfortunately, as humans, when a new human comes into the world, a baby is born, they pretty much started with 0 weights and 0 biases, if you really think about from a learning perspective. So you have to go through the entire motion of teaching this new human from 2 + 2 to the most complicated equations, to social behavior, to everything. And that learning, which is those gradient descents, those weights and biases, have to be baked into the human. Now, we don't need to do that in reality in terms of what we do with any kind of learning systems on the machine. So with this insight in mind, as humanity, we turned into creating large language models. I think you have heard enough of it, but I'd like to take a different view on it briefly. Large language models actually get trained by taking large amounts of data from the internet, from books, from different places. Today, it is even multimodal, which is image, audio, video, and text coming together and being put together. The words that you see from the text perspective are converted into embeddings, which is special type of numbers or special vectors of numbers. I'll come to it. Why it is important, I'll come to it very soon. It is trained by unsupervised learning first. That is, we can't label all the data on the internet. So we just say, hey, you know what? Read this up, figure out different buckets that you think is right. The output that comes from that learning is actually those weights and biases that we saw in the gradient descent of learning, the equation which, or rather the graph which I showed for the curve. That weights and biases is called as the foundation model. This foundation model, for the lack of terms, we're calling it as a foundation model because that is where things begin from. This foundation model is further taken ahead and actually fine-tuned for our needs. Both ways, fine-tuned in the sense of, okay, you have learned all these weights and biases. You can't speak harmful things and remove all the harmful context. That's one way of fine-tuning it. Or you can speak only medical terms. That's another way of fine-tuning it. Or you can speak only, say, for example, stock market terms. You can't speak any other thing. You don't know sports. You don't know anything else. You know only stock market information and all the jargon and the learning that you have. So that's another kind of fine-tuning. Now, with all this fine-tuning, there's one crucial step that we call as RLHF, or reinforcement learning through human feedback. You remember in the reinforcement phase, it was reward and punish kind of a thing. This is the approach that is done even on the model in terms of saying, okay, you can't speak harmful things. You can't talk about killing. You can't talk about pornography. You can't talk about bad material. You can't talk about drugs and things like that. So there's constant back and forth that happens in the RLHF phase. Just to give you an example, I was seeing a documentary recently on Deutsche Welle television, or Deutsche Welle channel rather. They had interviewed a lot of people in developing or yet to be developed countries, say for example, deep in Africa or in Southeast Asia, where people are sitting and tagging conversation saying, this is bad. This is a wrong conversation that a person tried to have. You should have blocked this. They were talking about murder and you shouldn't have spoken about it further. And this kind of tagging is happening, which is basically the punishment part of reinforcement learning, saying you can't do that. It's wrong. You should have said this in that case, or whatever it is. So RLHF is a very important phase as to where we are heading. And if you really look at it, just to give you a feeling of embeddings, I'll come to why I'm speaking about embedding so deeply and why I'm focusing on this, because one of the approaches of doing responsible AI is figuring out the right kind of embeddings. For example, embeddings are very simple. You're taking any kind of text, image, or audio. Basically, video is a combination of audio and images put together at different frame rates. And you're making vectors out of it in high dimensional space in a very simple way. Even if you just take 2 dimensions, if you have this as a vector of the famous example of king, queen is a vector which is very close, man is a vector which is very close for the king, and woman is a vector very close for the queen, for example. The same way, if you see some of the vector examples I've given here, is you have check and currency coming together, there'll be a vector called krona. And krona will be represented as a number in, for the lack of terms, in let's say XYZ space. Check is represented as another vector in XYZ space. Currency is another vector in XYZ space. Some form of function of check and currency. I've just put a operator as plus here. It need not be an operator of plus. So don't think it is 2 vectors getting added, but it's some form of operation will lead to krona vector, for example. Same way, Vietnam plus capital is Hanoi, German plus airlines is Lufthansa, so on and on and on. So what they're actually doing is they capture both the semantic understanding, which means to say it understands the word German and it understands the word airlines, and also the syntactic meaning of it. That means how these words should come together. Does German airline as a word come close to each other, or they come 100 words apart from each other? So both ways it is trying to capture the meaning by going through all the text of the internet, how much ever humanity has generated so far, in terms of books, in terms of, I don't know, even the tweets, Facebook posts, Insta Reels, everything put together. So because of this, it is able to do the learning, which you saw as gradient descent, coming to the minima, to saying, oh, now I know what airlines mean. Now I know what Vietnam means. So if I put Vietnam and airlines, I should be able to get an answer. This is typically how it actually functions, except that it does it in hyperdimensional space, I mean, multi-dimensionals, up to billions of dimensions, not just only 2 or 3 dimensions. So that's why it is complex data. It's very hard to handle. It's a time-consuming process to put all this together. So similar objects will have similar vectors that are close to each other in space. Just to give you an example, a cat and a tiger will be close to each other in vector space. Now, the fun part is what Jerry Kaplan, the person I showed you who invented the stylus of the Apple Pencil, said to me was, Jayant, have you ever thought that there is so much space between these vectors, which is infinitely divisible? What if we apply compute, or what if the AI algorithms are able to figure out what is between the spaces of cat and tiger, which we don't have a language, we don't have a label for, but maybe there is a label for it. Say, for example, when somebody said, I will breed a lion and a tiger together, they got a liger example, which is a real world example. But there's so much space in between that, as in the vector space, you don't know what could come up. And what are the different types of concepts, or what are the different types of semantics that could come up? These are things which we can't even imagine are actually existing in that negative space between two vectors. Now, this is very, very crucial to understand as we go along. So as I said, once this is done, once the embedding is done, and once the foundation model is built, we do the reinforcement learning. I was telling you about people sitting in Nigeria or Kenya or any of the African countries or the Southeast Asian countries. They go through a lot of bad content, and it's mentally very depressing to go through all that content to mark saying this is good and this is bad. You're basically rewarding and punishing constantly. This is the approach of reinforcement learning. From now on, I'll just call it as RLHF for easier kind of putting it together. So once all this is done, is what you're actually getting as a large language model. Large language model is not just about language model of I'll be able to go to ChatGPT and actually chat, and I'll be able to communicate back and forth, ask my question, and I keep getting an answer. It's actually much, much more than that. If, as I said, these are vectors, there's a lot of space in between the vectors which the algorithm understands, or the machines understand. We haven't, as humanity, we haven't, because that is the body of work which we have done is only these two vectors. The body of work in between that is still not there. So this is where the hard part starts happening. This is where the gray areas start coming. So if you really think about it, the machine or AI is actually a mirror to us. It is actually telling who we are as humanity. So you see, if you see certain kind of replies in ChatGPT or any of these large language models, I don't want to just only tell ChatGPT, it has actually learned the average function. As I said, if I give it a data set, it tries to draw an average function. It has learned the average function curve of the entirety of what humanity is, which means to say it is taking all the biases of what we humans are. If we are racist, it has taken that in. If we are biased towards certain things, it has taken that in. If we are evil in some senses, it has taken that in. If we are, say, for example, doing the wrong kind of things which harm the environment, it has actually learned those concepts. It has learned the concepts in terms of vectors and all the negative spaces in between, but it has learned that. The point that I want to really bring upon and enforce is humanity is seen as you see yourself in the mirror. That mirror is AI today. It's very unfortunate that we have distilled the entire of humanity into large language models, which is basically the mirror. It is showing us ourselves what we are seeing. If you see it, the supervised learning, the labels are generated by us. Unsupervised learning, we are the ones who are feeding all that data. It is not taking sensor data from the environment and then putting it together and saying, oh, there's a concept called as murder. No, that's not how it's happening. Murder as a concept, it has learned from humans by reading human data. Reinforcement learning, we are correcting that data, as in there's a team of people sitting deep in Africa or deep in Southeast Asia, deep in Mexico, maybe even in India, where people are sitting and telling, okay, this is how you should do this. This is what you should not do. So in essence, these large language models, or these function approximators, as what we said, carry all the weights and biases of what humans are in essence, and they are the average of that. So whenever they try to optimize themselves, they are going to be the best version of us in an average sense, not in one particular sense. So now you start seeing the problem areas that start emerging because of this. If you really think about it, are we, first of all, clean that we are telling that the AI should be clean? So if we have biases, if we are racist, how will the AI not be a racist? Because it has learned from that data set only. It can't learn from anywhere else. It has reached those minima points from our data sets. It is representing that vectors from our data sets, not from somewhere else. So in essence, you'll start seeing problem areas starting to emerge. Just to give you an example, I call this as representation, fairness, security, and transparency, kind of 4 different pillars that we really need to think about as to how do we start grappling with this problem. Supreme Court of India has made a hackathon, and in this hackathon they are asking, please build large language models, or please build foundation models, or derive from other foundation models, so that you'll be able to translate court cases from one language to the other, or bring it to one particular standard. As you remember, in unsupervised learning, we said we are asking it to make its own clusters and buckets. Bring about unsupervised learning approach that you'll be able to cluster similar cases together. Now, if you start thinking about it, tomorrow's judges or tomorrow's lawyers, if they start using this kind of technology, there's going to be inherent bias in how certain cases are going to be dealt with. Let us say I give you a presupposed average information that, you know what, 8 out of 10 cases in agricultural land dispute, the son or the daughter is at fault. If I give this statement as a general statement, because the data set is saying that, the likelihood of the lawyer or the judge leaning into that statement is higher. And you start seeing that there's a certain amount of discretion that is lost from the human, because they're seeing the data. And human mind is trained exactly the same way as the machines are learning. So we will come to the same minima points as what the machines are learning, because we see data. Typically, we do that, right? When we want to buy certain thing, we read the reviews of a certain product and we come to the conclusion, hey, yeah, this is a good product, for example. But imagine if you're doing that in a case of jury, in the case of legalities. Imagine that you're doing it with certain communities of people, or certain castes of people, or certain religion of people, or gender. It is going to be extremely, extremely hard to disassociate or to untangle this away from how things start working. So initially, you'll say, this is okay. This is going to reduce the amount of time taken to resolve cases, because it is helping the jury or the judges or the lawyers in a much faster way. But really think about it, you're at the same time biasing them in a certain way. So the representation of your data is actually biasing them in a certain way. The other thing is, LLMs are primarily trained in English. What about other communities? Say, for example, is cases that were dealt in, say, Tamil or Malayalam or Kannada or Telugu, is that equally represented? The more the number of cases in English, one of the parameters in that entire large equation, as I said, the bias or the weightage of language and the outcome will be that. Say, for example, 7 out of 10 cases of certain agri-land thing is because of, whatever, second generation or whatever that is. If that is the outcome that is, leaning into, it could be that out of 10 cases it studied, or maybe 1,000 cases it studied, 800 of them were in English. The rest were in other regional languages across the country. So you suddenly start seeing that the representation or the amount of data that gets into it is far, far lesser. And it's a very big issue. Today, if you go to ChatGPT and you're trying to say, give me an output in Tamil or whatever it is, there's a lot of misrepresentation that's happening, because ChatGPT or any of these foundation models, not just ChatGPT, any of these foundation models are primarily trained on text of English. How much of the work of a lot of the books from a lot of the regional languages or a lot of other languages across the world have surfaced up, and these models are getting trained on it. Very little. And there's no data to say that, where they're saying out of 1 billion lines of data that I gave to the foundation model, 800,000 were, or 8 lakh were in certain language, 2 lakh were in certain language, and 100 lakh was in some other language. We never get this data out. So the representation of certain communities, certain marginalized communities, start getting squashed, start getting suppressed. The smaller the community, the worse it becomes. Say, for example, if in India, if you consider, say, for example, a Parsi community who are very, very tiny, are we able to take all that from their language and represent it appropriately? I don't know. Maybe not. The same way, how do you know that the data that they're collecting from you is actually not being used to train certain aspects of AI? This particular screenshot is actually from ICICI Bank. You can go and check this. Okay, this is on ICICI Bank portal. They're saying AI is being used in lending and AI is being used in loan assessment. So next time you apply for a loan, your application is going through an AI model, essentially. Now, you don't know what parameters are being used to reject or approve your loan application. Previously, it was a human. He was or she was following a rule set, and they were saying, okay, this person is applicable, this person is not applicable. Today, you don't know. Today, it is not just your credit score. It could be that you're living in a certain ward, in a certain city, which is having underrepresented population or a minority population. Just because the ward has more amount of minority population of a certain sector, a certain caste, or a certain group, maybe the AI is determining, saying, you know what, you shouldn't approve loan from this particular PIN code. You don't know. Because in the website, nowhere, not just ICICI, I'm saying in general, nowhere they're actually telling, I'm using these parameters in these particular ways to arrive at a certain weightage of this function. And I'm able to say, okay, I'm considering race, I'm considering ward number, I'm considering, say, economic status in that ward, average income, etc., to give a loan or not give a loan. Nobody is telling that side of the decision-making process. They're just telling you that, yes, we are using it because as a good corporate citizen, we should tell you that we are using it, so we are using it. But nobody is going to tell you what it is. Okay, so it's a very inverted approach towards being responsible and being fair about a lot of things. Being fair about, say, for example, a socioeconomic status. Just because a certain PIN code has a certain amount of socioeconomic status, you might be at a disadvantage just because you are very close to the PIN code or you are in that PIN code. You never know. So this is from the fairness perspective. Another example, this Bharti AXA, again, they use data-driven approaches. They use AI, machine learning algorithms. They have said it out openly. Perfect, no problem. Problem is, we don't know if women are being given the same kind of insurance premiums as what men are, or vice versa. We don't know if people from a certain community, because of their high sweet consumption, are going to be given less premium just because you have a certain surname or you're of a certain community. You don't know how these models are making these decisions. And we don't have the time to sit and read all the fine print. First of all, we don't read the fine print of insurance or a loan document itself, let alone the AI part of it or the ML part of it, which is even more complex and harder to understand. So you start seeing that there could be gender stereotypes also coming in. I was just a few years ago, we were doing a certain work for a certain customer, where the customer had a sense that, you know what, in our company, women are getting less promoted than men, especially if women are coming back to work after maternity. They just had the sense, the HR head had a sense there. And when the HR head told us that, we said, look, we can figure this out if you're giving us data. And when we saw the data, there was a bias. Most of the teams in that particular company were actually skewing towards not promoting women who are approaching their maternity age or just after the maternity age, fearing that the woman or the lady would leave the company for maybe a month or so for maternity holiday, and by the time they come back, there's a certain amount of revenue loss in terms of production or anything that is being done. So when this kind of inherent bias is there in the human system, that same bias is going to come because we are feeding the same kind of data set. So when you're actually determining an insurance premium, you just don't know today how the insurance company is determining your premium using these AI tools or ML tools. What are the parameters? What are the weights of those parameters? We have no clue about it. So in terms of security, it's even more harder. Just a few days ago, I saw this in September, and there's a good example of this is all the data on LinkedIn was leaked. And LinkedIn was using it for AI training of their own, AI engines. We don't know what that means. Did it go into the larger scheme of things for other companies, partners of LinkedIn, or is it just LinkedIn? We have no clue. What we see is what we see in the outbound news that comes in, saying all the parameters of people were used to train AI in the case of LinkedIn's AI algorithms. Now, what does this mean? We very confidently say, for example, if I am searching for a job on LinkedIn, I know my boss is also there. So what I do is I say, hey, you know what? Make it private. Only recruiters should be able to see, and ensure that recruiters from SAP are not able to see it, right? That's what I think. I have the right to privacy, and I have the right to privacy in the sense of don't show my email, don't show my phone number, don't show my photo, because people will misuse it, etc., etc. I can do that also. But once AIs learn it, and once the AI algorithms are baked in with that kind of data, all you're going to see is it is going to use data for minimizing or maximizing functions, whichever any of these companies are using for. So even if you're going to say, I don't want my photo seen, I don't want my email seen, I don't want anything seen, there are very rare cases where you're seeing, don't use my data for AI training. This flag hasn't still come in. And it has to come, because if it doesn't come, we are actually pretty much in soup as a societal approach. So these are really complex adaptive systems, as what we call. They're not simple systems like, I change something and I get something else. These are not deterministic, as we said. These are stochastic approaches. Classic example that happened in 1960s, 70s is in Yellowstone National Park. They said there's a lot of wolves, and these wolves are killing the deer population, so let's remove wolves. And they gave licenses for wolf hunting. Wolf hunting happened, and deer were living peacefully. But suddenly, after a few decades, or 1 or 2 decades, they started noticing that the tree cover in Yellowstone National Park had drastically reduced, because of which soil loss was happening, because of which rivers were taking a different turn and shape, because of which other ecosystems or other animals were suddenly missing. So a simple decision to say, I'm going to kill wolves, led to some other consequence somewhere else. This is exactly what's going to happen in this trillion parameter equation or function approximation, that you tweak one parameter, some other parameter is going to change. So this is not a simple solution that we are looking at. But what are the solutions that we start seeing? We start seeing debiasing embeddings in society. Now, debiasing is very, very important. Debiasing means to say reducing the weight of a certain parameter. Say, for example, reducing the weight of religion. You remember we spoke embeddings. You'll have a large data set in which religion is one column of the customer. You'll say, don't give any weight to this. Make it 0 weight. So this has to be done during training itself. Even before you're doing your foundation model, somebody has to sit down and think, what are the data I'm collecting from across the internet, or in the case of the bank or the insurance company, what are the overall data that I'm collecting, and which are the data points that I have to give 0 weights, for example. So that's called debiasing. This is, I don't know how much of this is being done, but this is not openly told by anybody that I'm debiasing these columns of data to ensure fairness or to ensure representation. One approach is what is called as AI nutrition fact. I think now India has picked up reading labels at the back of food products. Similarly, there should be AI products saying this AI was trained based on these set of parameters. This AI has used reinforcement learning where humans have trained it, the good and the reward and the punishment cycles. And the population of humans was 60% was Nigerians, 30% was Filipinos, 20% was Indians, and so on and so forth. So inherently, you're learning that this AI is going to behave in a certain way because 60% of Nigerians have taught it. That means to say 60% of the culture of the AI is actually Nigerian culture. Whatever you say, that's how it works. We are always being underrepresented. Today, LLMs are being written, but a community deep within, say, Karnataka or Tamil Nadu or West Bengal or anywhere are not being represented because these people don't have a way or a voice to say, what you're saying is wrong, my culture is different, and here is certain details of my culture, so relearn. This is not happening. So this is one approach wherein you're debiasing and at the same time you're giving some kind of a nutrition label in AI. The other approach is what is called as mechanistic interpretability. That means to say, today these function approximators are pretty much black boxes. We don't know exactly what is happening in there, but we should be able to put a tracer somewhere and actually follow the tracer. It's almost like an angiogram that we do. We put a tracer and we follow the tracer to see where the blocks are. So similarly, we should be able to put a tracer and we should be able to pick out those regions or those biases or those embeddings which are leading to a certain concept. Say, for example, leading to a certain decision making of saying, I should not give insurance of a certain premium to certain gender, say women, in a certain pin code. We should be able to pick that out and we should be able to clearly mark that out and say, this is what is happening. There'll be 3 phases itself. You could do it before, during, or after training, but this is the rough overall idea of mechanistic interpretability to say which neurons are getting fired in the neural network and what's the weights and biases on those neurons and how do we, I wouldn't say control them, but at least we know that, yeah, this particular rejection of this particular loan application happened because these neurons made a decision saying in this pin code, I should not give it. So at least we know that those neurons are responsible for pin code, for example. The last approach is what we call as concept erasure. Now, unfortunately, training large language models is billion-dollar affair. It's not even $1 million affair. People are buying billions of worth of GPUs. You must have heard in the news, and training OpenAI, ChatGPT models or Gemini models or anything. But one of the things that we can do once we finish the RLHF or the reinforcement learning process is what is called as concept erasure. Concept erasure is you should be able to say that this particular concept is being represented in these embeddings, and you should be able to de-weight or de-bias those embeddings only. This is even more harder than the last 2 approaches, but most likely we'll have to follow this approach because we have spent billions and trillions of dollars in already creating these LLMs. So this is a more tractable approach that we are having today than just blindly trying to retrain the whole thing, which is not a possibility, or trying to trace, but we don't know what we should do. But here in concept erasure, we should be able to choose a certain concept and erase it. Big disclaimer or big red symbol here. When you erase a concept, there is going to be a net effect somewhere else because it is the wolves and the deer story. You remove one concept, some other concept linked to it will also fall. And we don't know how these complex adaptive systems work with each other. The last approach, which is a much larger approach, is what the Indian government also is taking, is a policy-driven approach where we have a policy, we'll institute guardrails, we'll ensure human control is taken precedence over AGI or ASI kind of approaches. SB 1047, which is a legal condition in California, is saying if you are using more than X amount of teraflops of compute to train your LLM, you should tell about it, etc. But that is more like a governing or a policing setup, which is very much essential. But that alone is not sufficient because who will govern themselves? How are the bodies going to go check about was this particular application not given or not approved because of, we don't know how that is going to work. So this is in extremely early stages. I don't think this is going to take off. It's almost across the world, it is still very early. So in summary, bias has crept into AI algorithms. because it is the mirror of human society. It is the average of what human society is. Whatever text and audio, video, images we have generated, that is what it's got trained on. There is bias, there is bad parts of it. There are four main pillars, which is representation, fairness, transparency, and security, which we need to actually solve. Solutions are emerging, debiasing the embedding itself, which is in the training phase itself, or mechanistic interpretability of tracing where a certain decision is being taken, or concept erasure of removing the entire concept itself, but has certain side effects maybe. Policies have to come out really, really strong. And this is where we need to push our local governments to say, my community, my set of people are not being represented. How do we ensure representation? I think this is a fundamental question that we need to ask, and this has to start from grassroots level. Otherwise, what will happen is we are going to see runaway effects of this bias and amplification. As an amplification is, if you have seen one YouTube video, the next YouTube video is nearly similar. If you have bought one product on Amazon, the next product is nearly similar. This is what AIs will start doing because it is finally trying to optimize. I think that's about it from my side. I'll stop here. Any questions?
Dear participants, now the session is open for the queries. Please do raise your queries either by unmuting yourself or put your queries in the chat window so that I'll be reading that to Jain sir. Is it fine, sir?
Yes, ma'am. Absolutely.
Great. Participants, please be interactive.
Yeah, good evening, sir. Sir, the concept which you are delivering here today's session, all are theoretical kind of thing. So, is there any implemented or any tools are available to measuring which is correct or not, which is ethically correct, is responsible for the AI? Is a practical approach is there right now exist?
Yes, ma'am. So I have shared the slides with ma'am also. I think you'll be getting the slides. I would like to point your attention to the links at the bottom of these slides, specifically in the solutions part. There's code also available for each of this, but it is such a nascent field, ma'am. I don't know if the code is covering all aspects of what responsible AI should be. So what I have done is I have taken the most relevant ones, most fruitful ones which are working as of today. And I have also shared the code at the bottom of the screen, which you see the link in blue. You can refer to the code there and see how you can apply that particular concept or that particular solution in your particular case, if you're looking for something. But it's a very, very nascent field. If there's anybody from academia who is trying to pursue more in the direction of a doc or a postdoc in certain concepts, these are the three main pillars: debiasing, mechanistic interpretability, and concept erasure, which is having the most fruitful approaches today. There are many others, but these seem to be more fruitful than the others. So deeper research topics can definitely be found here. But would I give a tick mark of industrialized solution for these approaches? Not yet. No, ma'am.
So once again, sir, in the last yesterday session, I am again repeating the same question again.
Yeah.
Sir, what is the correlation between explainable AI and responsible AI?
So responsible AI, okay, let me take explainable AI. Mechanistic interpretability is one form of explainable AI, as to saying why a certain AI algorithm or a model has taken a certain kind of decision. As I said, why was my loan application rejected? You should be able to trace it back. Which are the neurons that get activated? Which are the biases that were there? Which are the weights that got activated, because of which it actually rejected my application? That is explainable AI. Whereas responsible AI is figuring out how do I debias the entire training itself that I'm doing, because there's a certain amount of bias and inherent weights that we have baked in at the dataset level itself. Can I work with that in different ways: pre-training, after training, or during training and after training? In all these three approaches, can I work with them in some way wherein I take the responsibility as a corporate or as the person who is building the large language model or any kind of AI model to actually debias or to actually remove certain concepts or to do it through RLHF also. It could be that somebody is sitting and telling the AI by prompting saying, no, you should not talk about this. It could be that. But am I taking that responsibility? Have I put that framework? Have I put that process in place in terms of doing it? Explainability is a part of this entire process, which is mechanistic interpretability. But that is not sufficient. You have to take the entire process and look at it as a whole.
Good evening, sir.
Good evening, ma'am.
Sir, actually, there are innumerable options for training. We couldn't actually train a system without bias. If I am building a chatbot, there are n number of options. I couldn't go for large and large data sets, isn't it, sir? So what I'll try to do is I'll place a restriction, and within that boundary only, I'll be training my chatbot. So what could be the other options that are used to enhance the performance? Accuracy is very important in case of these things, isn't it, sir?
Yes, ma'am. Unfortunately, ma'am, the way things are turning out today, at least as of even yesterday and day before, whatever OpenAI has released, they are actually training it with more and more data. They're not going the other way of not training it with data, because they are optimizing their bot to become the best, for example. So the more the amount of data you're giving at it, the more the amount of bias also you're giving along with it. There's no turning back on that. If we have to train our own data sets, our own large language models, you're still taking a foundation model and training on top of it, which is fine-tuning it or RAG-based approaches or whatever that we are doing. Because training something from scratch completely for only myself is very, very expensive. Companies are doing it, but it's very, very expensive. It comes at a very high level of expertise and also high level of infrastructure cost. So what a lot of companies are doing is actually they're taking in the foundation models and building on top of it by adding their own data, tiny amount of data, which is within the boundary of that company, for example, and then training. Say, for example, an insurance company will take their insurance data, add it into a foundation model, and then kind of adjust the weights and then bring out a model. This is how typically it is happening today, unless until there is a completely different approach of quantum computing, where if quantum computing becomes so good that you'll be able to train foundation models itself in 5 minutes, then it's a different story. But till then, this is the only approach which I think most of the industry is using today, because it's very expensive to train from scratch. Very few people are actually doing it.
Thank you, sir.
So we have 2 queries there in the chat window. Could I read it to you?
Yes, ma'am.
There is one query raised by Dr. K. Lakshmi. She's asking, can you tell me about the open challenges to start research in responsible AI?
Good question. The kind of open challenge, one is definitely mechanistic interpretability. I think this is long pending. We call it as explainable AI, but mechanistic interpretability is more apt. Even companies like Google DeepMind are investing heavily into it. There's a very famous person by the name of Neil Nanda. You can look him up. A very young guy. I think he's just 24, 25, but has done leaps and bounds in terms of mechanistic interpretability, which is a good amount of work in that. I have read 1 or 2 papers of his. So that's one area. One area which is really, really upcoming, again, as I said, is concept erasure, but concept erasure, not just in terms of I'm going to erase a certain concept, I'm going to identify a certain concept and erase it. I don't know, whichever approaches you want to use, say sparse autoencoder approaches or any other approaches that are there in the academic papers. But more so, what are the downstream effects of erasing a concept? I think that is even more crucial. Today, nobody is actually still focusing on it. If, say, for example, there's a concept of pin code getting more weightage in say insurance approvals. If you remove pin code as a concept, if you have removed that learning itself, what are the downstream effects of removing that learning? What's going to happen? I don't think this is still being done. This is still an open question. Ma'am?
Yes. Sir, I have a query.
Yes, ma'am.
Am I audible? Okay. The question is, if there is a fairness that is being lost or responsibility being forgotten during the development of that AI system, will it lead to machine unlearning, sir? Or will there be certain situations tomorrow leading most of the AI applications, crucial applications, since because ethics or responsibility or fairness, whatever the theme that comes under RAI, if it is not there, will AI itself recommend to unlearn?
This is a really hard question. I don't know how to answer this directly, ma'am. I'll be treading on speculation and more like conspiracy theory if I answer this, but I'll try answering this. If AGI kicks in, then there is a possibility of unlearning. But does that unlearning benefit humanity? We don't know. It's a complex adaptive system. We don't know the downstream or any kind of effects. But in today's context of today's AI systems, even the latest ones, which is ChatGPT O1 systems, which have the ability to do system to thinking, the unlearning won't kick in unless until we force it to kick in, because this concept hasn't been documented, hasn't been percolated into the training sets in any way. So whatever it is having, that it is taking the average in that training set and it is going to behave appropriately. If there is a certain amount of training set that is getting fed to it saying, I don't know, many terabytes of data saying, you need to unlearn a certain concept because it is dangerous for humanity, then it might. But otherwise, there's no active participation from AI to do it because it is just average function of the data set that gets available to it.
Okay, thank you, sir. Thank you.
Thank you, ma'am.
So we do have two other queries on the chat. I'm reading
Sure.
it to you.
Sure.
The next query is from Sasikala. She's asking you to explain MLP layer.
In the simplest way, ma'am, a multi-layer perceptron is multiple neurons which are connected with each other in such a way that one layer absorbs a certain concept, and that concept gets, with the weights, goes into the next layer, which absorbs a different kind of concept, which goes into the next layer. In a very, very simple way, the human eye, when light passes through it and goes into the back, this portion where we have the vision area in the brain, we have 4 different regions actually: V1, V2, V3, V4. I think V1 is for detecting edges, V2 is detecting motion, V3 is colors, something like that. I've forgotten. This was long ago. So essentially, think that each layer is actually detecting one kind of feature, or learning one, not detecting, learning one kind of feature in this particular case. One layer will learn how to do edge detection. One layer will learn how to do color. One layer will learn how to do motion. And these layers pass whatever it has learned in terms of weights. Say, for example, if there's A1x1 plus A2x2 is a simple equation with just two neurons, the next layer will have assumption is 2 neurons. The A1 and A2 are the weights. So it will pass that weights for the 2 parameters into the next layer, saying I learned this, and that will again change and it will pass again, I learned this. And finally, there is a certain prediction. If it goes wrong, it does what we call as back propagation, which is basically a partial differential gradient descent to the place where it has to change a certain weight and try to achieve a certain outcome. So this is how typically the entire neural network structure works. And the multi-layer perceptron is, just think literally like how our vision system works, that one layer is for detecting edges, one layer for color, so on and so forth. Each layer is doing one certain kind of feature job, let's call it that way. So put this together, you're going to get multi-layer neural network. Today, large models go in depth of about maybe 1,000 to 1,000 layers. I don't know publicly how much large language models are going because nobody discloses that, but large networks typically go up to even 1,000 layers, which is fairly complex approaches. I don't know if I answered the question, ma'am. Dr. Surya, ma'am?
Yes, sir, you have done it.
Okay.
I was actually waiting for the person who raised the query to get back to you.
Sure.
So then
Sir,
one.
Yes, sir. Please go ahead.
Sir, actually, I am asking about the students are now struggling to select a particular department after completing their higher secondary school, as well as the students who had completed a high school 10th. They are also not having any ideas to select their groups in their higher secondary level. Is there any AI tool which helps them to select their interests, sir?
At the moment, such a chatbot, I don't know if it exists, but I haven't seen. I have seen learning chatbots which help learn. Say, for example, Khan Academy has a learning chatbot called Migo and things like that.
Okay, sir.
But yeah, an interesting thing to see if you can put in your Facebook profile, your Insta profile, all the videos that you generally see, your educational records, your interests, your hobbies, all this data coming together. Maybe you can bring that together to see which vector would actually suit you. An interesting exercise, sir. Definitely interesting.
Okay, so now it's actually as in our college also all over Tamil Nadu also students after selecting a particular department they are saying I am not interested in this department, sir.
Yeah.
Then, actually we are facing this a lot, sir.
Absolutely. I think the fundamental thing, sir, is getting people to understand that the first principle learning and the fundamental learning, specifically math, is very, very crucial. Doesn't matter which stream of engineering you choose, because AIs will eventually, or large language models specifically, will eventually be able to do a lot of things. Today, 90% of a lot of the work that gets done in mechanical engineering or in computer science engineering, a lot of them are using LLMs. But having the understanding at a fundamental layer that they'll be able to construct things from first order differential equations is very good. Once they're able to do it, I think doesn't matter which stream they choose, I'm sure they'll be successful.
Okay, sir. Thank you, sir. Thanks. You people have to do some sort of things for this problem to be solved, sir.
Would love to, sir, and we are doing our little bit. Maybe this is not the forum, but would love to share more details. Do write to me. In the slide, I have my email ID.
Okay, sir.
I can have
Okay,
a
sir. Definitely, sir. Thank you, sir. Thank you very much, sir.
Thank you, sir.
We do have two other queries in the chat. I'll read it, sir. The next query is from Nachi Amai. For image processing, which machine learning language would be suitable? And her other question is it right choice to go with Anaconda?
Today, the most popular approach is still Python-based approaches. There are very beautiful models now. Zero-shot learning models have come in, or only one-shot learning models have come in. Check out a thing called YOLO, Y-O-L-O. You only look once. Basically, you are able to train a certain set of images, and in one shot, it is able to learn the features of those images and work with it. It is a Python-based approach. Anaconda is just a container containing all the libraries of Python that are essential for, let's say, AI ML kind of work that needs to be done. Definitely, you could use it. Some other approaches, there's a very beautiful package manager in Python called as UV, as in the letter U and the letter V. You can check that out also. But those are just package managers. I would say those will evolve and those will iterate out. But the models that are there, if you really think about it from a math fundamental first principle perspective, if students will learn convolution neural networks, the math behind it, they will understand image processing. I think if they are able to get to that, the library doesn't matter, or the approach doesn't matter, or even the language doesn't matter. They can even write it in, I don't know, maybe even they'll use whatever Excel sheet uses as a language, but they'll be able to express the math of convolution neural networks there, and they'll be able to do image processing. Yeah, it might not be efficient, but they are able to. Having said that, some of the popular languages that are taking off is Julia. As I said, I met the founder of Julia. So Julia is a very popular language for such work. It's replacing MATLAB everywhere. So it's a language to watch out for other than Python. Rust is taking up big time. A lot of the scientific computing community is picking up Rust. Of course, there are hardcore people still who lean back onto Fortran even today. And it is still a very effective language, no doubt about it. I don't want to not say that's a bad language, or say it's a bad language rather. So focus on the math behind it, specifically the first principles concept of convolution neural nets. Thereof, focus on one of the languages, either Python, Julia, Rust, if possible, and implement the algorithm, or learn how to implement the algorithm. As a matter of fact, you can ask students to do an exercise, ma'am, saying to ChatGPT, saying, teach me convolution neural network step by step from first principles to implementation in a certain language, and go by it line by line, and it'll actually explain it. And all they have to do is read it, execute it, read it, execute it, and they'll be able to learn image processing.
Fine, sir. So the last query is, give an example of mechanistic interpretability.
So as I was saying even earlier, say for example, if a certain decision in a data set is made, say the data set being loan disbursement data set, and a certain application is rejected, now you want to know why a certain group of people are getting rejected. As human eyes, when you look at the data, you might say they belong to a certain religion community. Because of that, the AI is rejecting it. Now, you want to be sure that that is the reason. That's a guess you have. That's a hypothesis you have. But how do you go about proving that certain neurons or certain nodes in the multilayer network got certain weights because of which this particular decision was reached? You have to go backward, and you have to actually trace it. I said, right, like an angiogram tracer, you will have to leave the tracer and you have to see it. So that is an example of a mechanistic interpretability, to saying that, you know what, layer 65, the 4 neurons on the top were responsible, and they got weights, and they throughput weights in such a way because of which the decision of this loan application rejection for a certain religious community happened. Right? So you should be able to pinpoint that, and then you should be able to detune those weights, or give instructions to detune that, and in terms of doing something. Or the other way, saying these were the 4 neurons that led through pornographic content. So you should actually increase the weightages of saying don't let such content through in some other data set. So the approach or the study of understanding which nodes and which neurons in your entire neural network is leading to what weights is what mechanistic interpretability is all about.
Thank you, sir. Thank you for your patience for answering all the queries raised by the participants. So we have come to the end of the session. I take the privilege for thanking you. On behalf of everyone present for this FTP on responsible AI, I extend the heartfelt gratitude to Mr. Jayant for an inspiring and enlightening session on responsible AI. Your insights into the system thinking, ethical considerations, and innovation have truly resonated with us. Your journey and contributions will serve as a motivation factor definitely for us, striving to balance the cutting-edge technology with responsibility and inclusivity. Thank you for sharing your invaluable knowledge and experiences, which will undoubtedly leave a lasting impact on all our understanding on AI and its role in shaping the future. Thank you so much for accepting our invitation and taking a session for this FDP on responsible AI, sir. Thank you so much.
Thank you, ma'am. And thank you for all the questions from all the participants. It was really nice and engaging for me also. It made me think a lot. Thanks a lot.
Thank you, sir.